Hi students, and welcome once again to Laboratory for Electronics 2 courses. Okay, so today's lab is all about active filters. Okay, so active filters is our laboratory number 8. Okay, so active filters, uh, we have the low pass filter, we have the high pass filter, the band stop, the band pass filter. Okay, and the main objective of this experiment is to plot the response curve of a silent key second order active filters. Okay, calculate the roll-off rate of the filter. Okay, and comment on the effect of using positive and negative feedback to improve filter frequency response. Okay, but today's experiment, I'm gonna show you only the low pass filter, no, using the operational amplifier 741. Okay, all right, so let us go to the equipments used. So we're going to use the equipment IC LM741. Of course, the operational amplifier, it's here. I already inputted there. Okay, and a function generator. Okay, here, this is a function generator of our KNH trainer. All right, okay, a positive and negative 15 volts. Okay, it's also here. All right, so resistors 1K. All right, so we need resistors 1 kilo ohm. Okay, 1 kilo ohm resistors here. Okay, I'm gonna get one. So 1 kilo ohm resistor. All right, and what else? Okay, a 10 kilo ohm resistor. All right, so you'll be needing also a 10 kilo ohm resistor. Okay, so I'm gonna get 10 kilo ohm resistor. So it's here, no? 10 kilo ohm resistor. Okay, and a 39 kilo ohm resistor. So here it is, no? 39 kilo ohm. Okay, all right, and lastly, the 10 nanofarad, no? So this one, 10 nanofarad. Okay, capacitor. Okay, and the code for this capacitor is 103. Okay, for 10 nanofarad. All right. So once you have all the necessary components, then we will connect the circuit for circuit number 1, no, the low pass filter of first order silent key. Okay. So there's a question here, no? So calculate a low pass filter of first order silent key with gain equals to 5 and cutoff frequency 3000 Hertz. Then assume that capacitor is 10 nanofarad and R1 is 10 kilo ohm. Okay? So design the frequency response, no, of this low pass filter. All right. Okay. Now, so we need to connect, no, this one, no. So first of all, you need to connect the frequency for the function generator, no. So function generator. So from here, the output of the function generator here, connect it to number 3 of the operation amplifier. So 1, 2, 3. So I'm gonna connect it here like that. Okay. Once connected, then, okay, so before that, you need to connect a 5.6 kilo ohm. Okay, so we need to get a 5.6 kilo ohm first. So where's that 5.6 kilo ohm? So let me check let us check it here. 5.6 kilo ohm, no? Somewhere here, this one, no? Okay, so I'm gonna get the 5.6 kilo ohm. Okay, so connect it here, okay, along with the input, and connect it to number 3, pin number 3 of the, okay, like that, no? 1, 2, 3, no? 1, 2, 3. Pin number 3 of the operational amplifier 741. Okay, once done, then get your capacitor, the 10 nanofarad. Then connect it also here, no, number 3, like that. Okay, just be careful, like that, no? Okay, so this 5.6 and number 3, the capacitor are in one, okay, are in common connection, no? And then that capacitor will be connected to the second leg will connected to the ground, like this. Okay, and of course, you need to connect also this ground to any ground, no? Any ground of the board. Okay, so our out, okay, here, like that. Okay, any ground of the board. All right. So what's next? Okay. So you need to connect number 2 to number 6, the 39 kilo ohm. All right. So this is the 39 kilo ohm, no? The orange, white, orange, no? So number 2, okay, the number 2 here, connect to number 6, no? 5, 6. That, no? Okay. And then the 10 kilo ohm, connect also to number 2. Okay. Number 2 to ground. Right, so I'm gonna connect it here. Same, number 2 of the pin number 2 of the op amp. Then I'm gonna connect here, no, common, no, to the ground, no, of the capacitor, no, 10 nanofarad. All right. Okay. Okay. After that, the 1 kilo ohm, connect it to number 6. Okay. Number 6 here. And to ground, no? So put it here, no? Same ground, no? Of the 10 kilo ohm and the nanofarad. 10 nanofarad. Like that. Alright. Okay. Once done, then connect the power supply, number 7. Here. Here. This is number 5, 6, 7. No? Here. So 7 to positive. Okay. And the number 4, no? So 1, 2, 3, 4 here, no? 4. Connect it to the negative supply. Negative 15 volts. Variable, okay? Okay, like that. Okay. All right. Then, of course, no, the BNC to banana, no, connect it to channel 1, no. This one, no, channel 1. Channel 1, connect it to the input, no. The input. Okay. Okay, so the red will be in the input. Of course, the black will be the ground. Like that. Okay, and the other one, channel 2. This one, no? Connect this one to channel 2. This will be the output, no? Number 6. Okay, and the ground. Right? So switch on the, okay, switch on the, once done, then this is your final circuit. Okay, so this is your final circuit. All right, so let's take a look so that you can see how it's being connected again, no? Okay, so this one, no, the probes connected to the oscilloscope. So let us switch on the oscilloscope. Okay, so I have the yellow is the channel 1 and the pink one or the purple is channel 2. Okay, all right, let us switch on. Okay, so look at here, no, you have already the output. coming from here, no? So now our input should be AC, no? So put this one to AC. Like that, no? Put this one to AC. Okay? Now here, put it to 2K. And this one, if you cannot read, reduce the amplitude. That. Okay, so that you can see clearly. Okay. All right, adjust this. Okay, now you need a 1 volt, no? 1 volt peak to peak. So look at here, the yellow is 5 volt, no? See here, the yellow is 5 volt. This means the input is 5 volt. So we will reduce the amplitude here, no? This amplitude. But first, the frequency, okay, the channel 1, so that's our input, should be 1 kilohertz. So adjust the frequency here. No, adjust until such time you will get 1 kilohertz. Okay, now you cannot see it, so adjust the time division, expand it so that you can see clearly. Okay, now it's 757, so adjust, make it 1K. Okay, that's the initial, huh? All right, and then the volts per peak to peak, adjust the amplitude, no? Here, no, this one, no, amplitude. Adjust it, make it 1 volt. Now you cannot see it properly, so increase this one, no? Okay, so that you can see properly. So make it 1 volt. Okay, look at the yellow, no? Okay, that's approximately, no, 1.04 is the 1 volt peak to peak. Okay, and this is your output, no? Okay, so the output is this one, no, channel 2. Okay, but the frequency you don't know yet. All right. Okay, the output there is 4.56 peak to peak. Okay. All right. Now, what you need to do is that to change the frequency, no? Okay, start with 20 hertz. Okay, 20 hertz. Then get the V input, V output. V input should be all the same, no? It should be 1 volt. No, every time it should be 1 volt. Okay. All right. So adjust this frequency. Adjust the frequency. So look at the frequency in the yellow. Make it 20 hertz. Okay. So adjust this so that you can see. Now it's 95. Okay. Now here. Let's start with 100. 100 hertz. Okay, there, 100 hertz. Okay, check the output. Okay, so the output is 4.96. Okay, for 100 hertz, right? And the input is 1 volt. Okay, then after that you do 200 hertz. Okay, then write the output. The output still, no, is 4.96 volts. Okay, 200 hertz, and the input is 1.02. Okay, adjust the time so that you can see it properly. Now after that, make it 300. Okay, adjust the frequency in the function generator. Make it 300 approximately. Okay, and input the output. No, the output is still the same. No, 4.8 volt. 4.8 volts. Okay. Now next, 400. Okay, that's 400. Okay, input is 1.02 or 1 volt. B peak to peak 4.8. Next, 500. Okay, 500 approximately. Okay, still 4.8. Next, 600. Okay, now still the same, 4.8. Next, 800. Okay, make sure the input still the same, the 1.02. So 800 approximately. Okay, that is 4.56. Okay, next 1K. Okay, 4.56. Next 4K. Okay, now my frequency is max here, no? So the max. So what will I do? I will increase the range to 20. Okay. Then I will reduce, no? I will reduce this. Okay. So next is 4K. 4 kilo ohm. 4 kilohertz, sorry. Okay, now if I cannot see it, to increase this time, I can see it properly. So make it 4K, no? Okay, like that, no? So 4K, 2.88 volts, no? The output there, no? In the purple. Okay? But the input is still the same, no? 1.02. Now increase, make it 10K. 10K. Now the V peak to peak is 1.6 volts. Okay? After 10K, make it 20K. Now it's 20K. Now the V peak to peak is become 880 millivolts, no? And then after that, 60K. Okay, oops. Now this is maximum. Put this one to 200. Okay? 200 and put it back like that. A little bit. Then increase the time so that you can see it properly. Increase also this one, no? Like that. So you can see it properly. Alright, make it 60K. Okay? Now look, no, the voltage become about 300 plus, no, millivolts. Okay? So it's getting smaller and smaller. No, that is 60K, and make it 80K. Okay, now it's become 200. Alright, and make it 100K. Kilohertz, 100 kilohertz. Okay, now it's become 160 plus, no? Okay, it's decreasing. Look at the B peak. Look at the B peak to peak. It's decreasing. All right. Now make it 200. Okay, now it's become the least is 64. No, take the approximate. So one thing for sure, that the output of this circuit is decreasing while the frequency is increasing. All right. Okay, and that's it, no? So up to 300K only, 200K. All right, because our function generator maximum frequency is up to 200 kilohertz only. All right, so that's it for the experiment number 8, no? The silent key low pass filter. Okay, so this is the only we can do for now, no? For the practical, no? The rest of the active filters, okay? The rest of the active filters, there are high pass filter, no? Okay, so for the high pass filter, please do it using the multi-sim, okay? And answer this student assessment, okay? All right. So thank you, and good luck.